Hello. In this video, I'm going to show you how to solve for t, or the time of compounding, when we have a couple different types of finance formulas. One of the most basic formulas is just a future value formula. So if we write that the future value of some cash flow at time t, we can say that that is equal to the present value at time 0 times 1 plus r, whatever the interest rate is, raised to the t. So in this formula, we could use that and rearrange it to determine how long it might take for a certain amount of money to double, for example. Right? You might start out with $100. You're going to grow that at some interest rate for t years, and you want to know how long it takes for that to become $200. So to do that, we have to do a little algebra. So we're going to start out by moving that $100 over. So if we divide through by 100, we're ending up with 2 equals 1 plus r to the t. Now the big trick here is we have to use logs to be able to get that t down lower so we can use some more algebra on it. So the way we do that is we're going to use logs or natural logs. So we can take the natural log of both sides. And in this process, we can now pull that t out in front. So we can now say that the natural log of 2 is equal to t times the natural log of 1 plus r. So our final step then is to say t is equal to the natural log of 2 over the natural log of 1 plus r. So if we wanted to adapt this now, say we want to know how long it takes for the money to grow from $100 to $1,000, right? Instead of that 200 back here, that becomes 1,000. This becomes 10. And all that changes in our formula now is we have natural log of 10 divided by the natural log of 1 plus r. And that should give us that time t, how long it takes for our money to grow from that initial amount to that future value amount. Now let's look at a slightly more complicated example, but using the same technique. So here we're going to look at the present value of an annuity. So we can write the present value of an annuity as the present value at time 0 is equal to the cash flow at times 1 times 1 minus 1 plus r to the minus t, all divided by r. So we're still going to have to isolate that t so we can know how long it takes, how many periods we need to compound to achieve a particular present value. All right, so to do that, let's start out by moving everything we can to the left-hand side. So we're going to have present value 0 times r divided by cash flow 1 is equal to 1 minus 1 plus r to the minus t. All right, we can get rid of these parentheses now, and we can flip sides of these two terms. All right, we're going to add 1 plus r to the minus t to both sides and subtract present value times 0 times r divided by cash flow from both sides. We then get 1 plus r to the minus t is equal to 1 minus present value 0 times r divided by cash flow 1. All right, now we can use that log trick. So if we write natural log out in front, we do the same thing on both sides, being careful to keep all of that inside the parentheses on that natural log operator. We can then take our negative t, pull that down out front, and say that negative t is equal to the natural log of 1 minus PV0 times r over CF1, all divided by the natural log of 1 plus r. So that again, natural log allows us to pull that exponent down into the front as a multiplier. Then we can use our algebra just to isolate everything on one side to really make that t off on its own. The last step obviously would be to carry through that negative to the other side. You just put a plus there and a minus on the other side. All right, so that's the last step, and that should get us to isolate the t. That way we can solve for it and use it in our models.